Okay, we want to look at the graphs on a couple of these problems. So from problem number 6, we were looking at the function square root of 15 plus cosine squared x. That's the cosine of x, and I gotta square it here, so cosine squared x. Now, we may not know what the graph of that thing looks like, but if you think about it, cosine of x is always between -1 and 1. The square of that would always be between 0 and 1. So this would always be between 15 and 16 inside there. So you're talking about a function that just fluctuates between square root of 15 and the square root of 16. So this is what it looks like then, fluctuating between those values. We only wanted to know the limit as x approaches 0. Limit questions are really asking what happens if I take a magnifying glass and look right around when x is equal to 0, what happens? So I'm going to zoom in on that some. And we're talking about what is the output, what is the y value when x is really close to 0. So for values around here, we get, well, look at what happens to your y. It's very close to 4 for all those. Nothing very interesting happens. F of 0 is 4. If I'm really close to 0, well, it's close enough to round off to 4. I mean, it's very, very close to 4. So that's one of the things that can happen when a limit exists. Sometimes the point is actually there and direct substitution will tell us the value, and sometimes it's not. But we don't really care what happens at 0. We care what happens when x is approaching or very close to 0. If there's this kind of consistency with all of the outputs being very close to something, then that's our limit, is 4 for this one. A little different from that on number 7 because we do have something strange happen, but we do have this kind of consistency. We were looking at the function x to the 4th minus 1 divided by x minus 1. And so let me get back to the overall look at that graph. Wow, that looks like a cubic or something, doesn't it? Now, we did the algebraic simplification to explain why it looks like a cubic. But even without that, we can think about the limit as x approaches 1 of this thing. We're interested in what happens when x is very close to 1. So let's take a close look there. We don't have as much consistency, but we do have a smooth curve around there, except something weird happens when x equals 1. Sure enough, it's undefined, so I don't get a number there. There is no f of 0. But I'm not asking about f of 0. I'm asking about when x approaches 0. You can almost see a hole there because they have left out a dot on the graph, but you can barely see it. That's not important for a limit question. What happens when x is close to 1 is my y values are close to 4. Now they're spread out a little more than the other one was, but they're still consistently close to 4 when x is close to 1. And that's the idea of a limit. Now to verify something like that, we had to do the algebraic simplifying to find that, but the graph tells us for sure all of the y values are close to 4 when I'm in that neighborhood, so saying the limit is 4 makes sense for that one in a different way.